Dear students, today we will study about the factors affecting equilibrium state. Now remember that the equilibrium state can be changed by changing the conditions like concentration, temperature and pressure. Now whenever some change is brought about in the equilibrium state, the system will either move in forward direction, either it will move in the backward direction in order to attain the equilibrium state once again. Now it's the Kc value which helps us to find out the direction in which the reaction will move. Either it will move in forward direction or in backward direction. It's the Kc value which decides that the reaction will move in which direction. Now different factors which are affecting the equilibrium concentration, these are: number one, if we change the concentration of reactants or changing the concentration of the products, both of these changes will bring about some change in the equilibrium state. By changing the temperature of the system, again equilibrium will be disturbed, and by changing pressure over the system, either increasing the pressure, either decreasing the pressure, both will bring about some change. Now in all these cases equilibrium will be disturbed and the reaction will move in such a direction in order to minimize the effect of these changes. All these changes, these will be discussed in the light of Le-Chatelier's principle. Now Le-Chatelier's principle states that if a system at equilibrium is disturbed by any way, the system will shift in such a direction so as to minimize the effect of the change. For example, if we change the concentration of the reactants, for example we add reactants, then the reaction will move in forward direction. If we remove some products from the reaction, then the reaction will again move in forward direction. And similarly, by increasing pressure, by increasing temperature, by decreasing temperature, all these are the factors which can disturb the equilibrium state. Now according to Le-Chatelier principle, this disturbance brought about by changing any of these factors, that will disturb the equilibrium, and then the equilibrium will move in such a direction so that it can minimize the effect of these changes, and it will reach again to the equilibrium state in order to attain the equilibrium condition. Now the equilibrium constant value depends upon the equilibrium concentration, and it is independent of the initial concentration. Therefore, if the concentration of any of the reactants or products is changed, the system will be no longer in equilibrium state. Now the first one is effect of change in concentration. The change in concentration can be brought about in the reactants or in the products. If we add reactants, if we remove reactants, if we add products or if we remove products, all these will disturb the equilibrium state, and the equilibrium will move in such a direction in order to minimize the changes which are brought about by the changing the concentration of any of the reactants or the products. Now let's suppose the general reaction, that is A react with B to form C and D. By adding any one of the reactants, that is A is added or B is added, or if we add both A and B, that will disturb the equilibrium. The system will be no longer in equilibrium state now. Then according to Le-Chatelier's principle, once you add reactant to this reaction, the reaction will move in forward direction in order to minimize the amount of A and B. So in this condition, Kc is now greater than the molar concentration of products divided by the molar concentration of the reactants. It means that the system has crossed the equilibrium state. You are going to increase the concentration, so that's why the system will move in forward direction to decrease the concentration of A and B, and again it will achieve the equilibrium state. Now by adding any of the products, that is C and D, the reaction is again, the equilibrium is again disturbed, and now in order to encounter the change, the system will move in backward direction. Let's suppose we are going to add C in this reaction, which is product, or we are going to add D in this reaction, which is product. Now the concentration of both the products are increased. Now the system will move in backward direction in order to minimize the effect of this added product. Now in such cases, Kc will be less than the equilibrium concentration, so the reaction will move in backward direction in order to maintain the constant value. Now these are the two examples in which we are going to add reactants or in which we are going to add products. Now by removing reactants or by removing products, what will happen? For example, the general reaction I have written that A and B react to form C and D. If I am going to remove A from this reaction, now the concentration of A decreases and the concentration of products will be higher than the concentration of reactants. So in such cases, the reactant will move in backward direction. The reaction will move in backward direction in order to attain the equilibrium state. If we remove B from this reaction, again the concentration of reactants decreases, so reaction will move in backward direction in order to form more and more reactants, and there will be a balance between the reactants and products. The removal of the products from the reaction mixture, how it will occur? If we remove the amount of products from the reaction mixture, then the concentration of products will decrease and the concentration of reactants will be greater. Then in order to minimize the effect of the change which you have brought by removing the products, the reaction will move in forward direction in order to minimize the effect of the change, and more products will be formed, and again a balance will be maintained between the reactants and between the products. Thus the equilibrium state will be attained or it will be achieved. In order to draw a summarized form from these all points, by adding reactants, reaction will move in forward direction. By removing reactants, reaction will move in backward direction. By adding products, the reaction will move in backward direction, and by removing products, the reaction will move in forward direction. Let's suppose I am again writing down the general reaction and I am going to summarize all these 4 points in a single reaction. That is, when I write down this A plus B, when go to C plus D, when I am going to add the amount of A to this reaction, it will tend to increase the concentration of reactants and the reaction will move in forward direction. If I am going to add B in this reaction, again it will increase the concentration of B and the reaction will move in forward direction. Now, on contrary to this, if we decrease the concentration of A, I am going to withdraw some amount of A from this reaction. The concentration of A is decreased. Now the products will move backward in order to form more and more A and B. If I am going to decrease the concentration of B, again the reaction will move in backward direction. Now let's suppose the same example repetition for products, that is A and B goes to form C and D. If I am going to add C or I am going to add D in this reaction, both addition of the products will move the reaction in backward direction. Now if I am going to remove some products from this reaction, that is I am going to remove C or I am going to remove D from this reaction, it will continuously compel the reaction to move in the forward direction. Now if you are going to remove C, you are going to remove D, in both the cases the reaction will move in forward direction. That is the effect of concentration upon the equilibrium state. Now next is the effect of pressure. The effect of change in pressure upon the equilibrium state. Now there are two conditions. One is when the number of moles of reactants is equal to the number of moles of products, and second is when the number of moles of reactants are not equal to the number of moles of products. Now in both the cases, what will be the effect of change in pressure upon the equilibrium state? The first one, when the number of moles are equal. Let's suppose the example of hydrogen and iodine to form hydrogen iodide. Now if we see, there are 2 moles on left side, reactant side, and 2 moles on the product side. Now the number of moles of reactants are equal to the number of moles of products. In such cases, pressure will have no effect on the equilibrium state, because number of moles are same in both the cases, the concentration, the amount of moles are same. Now neither the reaction will move in one direction, neither the reaction will move in the other direction, but it will move in both the direction with the same rate. Now one thing should be remembered, that the pressure has no effect on the liquids and the solids. When they are present in the equilibrium state, then such type of reactions that will not be affected by pressure. Now next is, if the number of moles of reactants are different from the number of moles of products, or the number of moles of products are different from the number of moles of reactants. In both the cases, there will be some effect of pressure. Let's see. I have written a generic reaction that nitrogen oxide react with oxygen to form NO. If we see the number of moles, so the number of moles on reactant side are 3 and the number of moles on product side are 2. It means the number of moles of reactants are greater than the number of moles of products. On such cases, once we increase pressure, the reaction will move in forward direction in order to minimize the number of moles of reactants and in order to produce more number of moles of products, and till the time that an equilibrium state will be achieved. According to Lechatlier principle, by increasing the pressure, the reaction will move in the direction where the number of moles are less. So that's why once we increase pressure on this reaction, so the number of moles are greater on this side and number of moles are lesser on this side. So it will move from left to the right, that is from in forward direction. Now if we look the example of the PCl5 when decomposes to form PCl3 and Cl2. So on left side, on the reactant side, we are having 1 mole, on the product side we are having 2 moles. Now by increasing pressure on such reactions, the reaction will move in backward direction, because the number of moles of products are greater than the number of moles of reactants. So when pressure is increased on these reactions, it will move in backward direction and more PCl5 will be formed. Now the opposite is, if we decrease pressure on such reaction, so it will favor the forward reaction. By decreasing the pressure on these type of reaction, the reaction will move in forward direction, and by increasing pressure, the reaction will move in backward direction. Now next is the effect of change in temperature. So on the basis of temperature, or on the basis of heat changes, we are having 2 types of reactions. One is endothermic reactions, in which the heat is absorbed and the heat of the reaction delta H will be equal to positive, and exothermic reaction, in which heat is evolved and delta H is equal to negative. Now according to Lechatlier's principle, endothermic reactions are always favored at high temperature. That's when we increase the temperature of the system, it will move in forward direction, and the exothermic reactions are favored by decrease in temperature. That is, when we decrease the temperature, the reaction will move in forward direction. Now let's see the example of carbon monoxide. When carbon monoxide react with oxygen to form carbon dioxide, so in this case heat is evolved, that is the value of delta H is negative. It means the reaction is exothermic. So as the reaction is exothermic, so by increasing temperature, the reaction will move in backward direction, because the forward reaction according to Lechatlier's principle will be favored by decreasing temperature of exothermic reaction. Now in order to minimize the heat, the reaction will move in backward direction once you increase temperature of the system. Opposite is, when decrease the temperature, so the reaction will move in forward direction and more carbon dioxide will be formed in exothermic reaction. Now another example, the endothermic reactions, when nitrogen reacts with oxygen to form NO. So in this case, The heat of the reaction is positive and it will be favored by increasing the temperature. So by increasing temperature, the reaction will move in forward direction in order to form more and more nitrogen oxide. When we decrease the temperature, the reaction will move in backward direction in order to release heat. That will be the opposite reaction will always be exothermic reaction and the forward reaction will always be endothermic. So forward is favored by increasing temperature and backward reaction is favored by decreasing the temperature of the system. So conclusion which is drawn from this whole discussion, there is for exothermic reaction, we increase the heat or increase the temperature, reaction will move in backward direction. Once we decrease the heat for exothermic reaction, then the reaction will move in forward direction. For endothermic reaction, if we increase the heat of the system, the reaction will move in forward direction, and if we decrease the heat of the reaction will move in backward direction. So that's all about temperature, that once a system is at equilibrium and you are going to bring some changes in temperature, so these type of effects will be produced upon the reaction. Now the effect of catalyst on the equilibrium state. Remember that catalyst has no effect on the concentration of the reactants or the concentration of the products which are present in equilibrium state. It has nothing to do with the Kc value of the reaction, but it only decreases the time to reach the equilibrium state. Now catalyst is defined as it is the substance which can only increase the speed of a reaction by decreasing the activation energy of the system. It is such type of species which cannot take part in the chemical reaction at all. It is not involved in the reaction. It is not going to change the concentration of the reactants or products, but just it decreases the time to reach the equilibrium state or the time to reach the completion of the reaction. For example, I have drawn a graph. The red is shown, that is the activation energy in the absence of catalyst. When catalyst is absent, so activation energy is high. All the reactants must have to reach this place in order to be converted into products. Now it will take more time in order to reach this place. But when catalyst is present, then the reactants will move towards this place, that is the activation energy in the presence of a catalyst. Now there is a big difference between the two. Now the reactants will move at this place and it will be converted into products easily. So catalyst has just decreased the time in which the reaction will be reaching to completion, or reaction will reach into equilibrium state in terms of equilibrium, in case of equilibrium. Now the equilibrium will reach earlier in presence of catalyst. The equilibrium concentration will always remain constant. They will not be changed by catalyst. So no effect of catalyst on the equilibrium state. Now this is all about the effect of changes brought about by temperature, pressure. Catalyst has no effect, and one is pressure, one is temperature, and one is the concentration. So all these are studied in the light of Lechatlier principle. If you like this lecture, so please subscribe my channel and press on the bell icon in order to get notification of the new videos. Thank you.